Hello students, welcome to the next video on heat. Again, this is based on middle school physics. We already learned that heat is a form of energy. The word is energy, and energy is measured in a unit called joule, capital J, single letter. The heat is a form of energy. Now, what decides the flow of heat? The heat will always flow from a higher temperature to a lower temperature. So, it is temperature which decides the flow of heat, temperature. So, temperature can be measured in degree Celsius or degree Fahrenheit. There is another unit that is called Kelvin, and later I will explain about Kelvin to you. Right? So, you can measure in degree Celsius or degree Fahrenheit. In one video, I will shoot the conversion and the numericals based on that. In today's topic is about transfer of heat. How is heat transferred? What does that mean? How is the heat energy transferred from one body to another body, or from one part of the body to another part of the body, or from one place to another place? In our discussion today, we are going to study about heat transfer or transmission of heat, any word you say, modes of heat, anything, that's one and the same. Heat can be transferred by three processes. One is called conduction, and another is called convection, and third mode of transfer is called radiation. These are the three modes, M-O-D-E-S, methods, right? Modes of transfer of heat. One is conduction, convection, and radiation. Today, first we will start with conduction. What do you mean by conduction? You might see that, for example, in your house, let us say, in the gas burner, right? In the gas burner, gas is heat is coming. Okay, the burner is flames are coming up. Okay, this is a gas burner. Now you take a vessel, for example, a vessel, and place it on this, and place water. Okay, put water into this, and suppose if I suddenly go and touch this vessel here, what will happen? I will feel the heat. I'll feel very hot. Okay? So, you cannot touch it because heat is here. And heat is heating this stainless steel or anything you take. Stainless steel vessel, and slowly it heats up all the parts of the stainless steel first. Okay, so this is getting heated, and when you touch it, you feel hot. Another example I can give you. For example, you take again a gas burner. Okay, flames coming up now. Okay, let us say it's a gas burner. Keep this in mind. Okay, you do one thing. You take a spoon. Okay, let us take a spoon. It's all experiment. Don't try to do too much. You will burn your hands, right? See, I take a spoon, right? And then what I do, and I'm going to keep my hand here. I'm going to keep my finger here, and I'm going to hold the spoon. Okay, let us draw the spoon a little bit better. I think it doesn't look like a spoon, right? So it's like a spoon. Take this like this and keep it here. And within a fraction of a second, you'll feel your hand is hot, and your hand will get hot, and you will drop the spoon. Why? The heat is transferred. The heat is transferred from the flame here, gas, and that is transferred quickly, and it is transferred to your hand and you drop it. Now why does this happen? And this mode of transmission in solids, usually this is happening in solids, and this is called conduction. Now, how does the conduction take place? I am going to tell you now the process of conduction. For example, I take a metal rod, okay? I take a metal rod and I fix it in a stand, okay? Now there is a retard stand. I have taken a stand. In the stand, I have fixed this metal rod. Let us say this is a iron rod. I fixed the iron rod. Now I am going to do one thing. I am going to fix thumb pin. You know, you use it on the boards. You know, on the display boards, thumb pins are there, right? Which is made up of a little bit copper coating, right? And this thumb pins, I am going to place it like this. Okay, let me place 3-4 pins like this. Okay. Now how will I face this? How will I fix these pins? I will fix the pins using wax, right? I will take wax, melt little wax, right? And let us take a small thing. In this wax candle is there. Take that wax and little melt the wax and dip it and fix it here, fix it here, fix it here, fix it here. At equal distances we will fix it. See, there is an iron rod, and I have fixed the thumb pins, okay? And what I am doing is, after fixing it, I am going to take a candle or something like which will heat a candle, and I am going to heat it here. When I heat here, this is the pin 1, pin 2, pin 3, pin 4, pin 5. I heat it here, and slowly the iron rod is getting heated. When the iron rod is getting heated, what will happen? The heat will be conducted, the heat will be transferred, and pin 1 the wax will melt, and the pin 1 will fall down. Pin 1 will fall down. Now the heat will again transfer, and it will come, and pin 2 will again fall down. Again pin 2 is fallen down. Here conduction is taking place, and so pin 3, pin 4 and pin 5, all the pins will one by one fall down, because the wax will melt with the heat, because the heat is given by the candle here, and the iron rod transfers the heat by the method called conduction. So what is that actually? Iron rod is made up of atoms of iron. You see, it is made up of atoms of iron. You know atoms? Atoms are nothing but a nucleus is there, and there are the electrons revolving around it. The nucleus of an atom consists of protons, which are positively charged, and neutrons, which are neutral, no charge, and electrons are revolving around that. This is just like our solar system. Sun is at the center and the planets are revolving around it. So like that, nucleus is the center with proton and neutron, and electrons are revolving around it. Now this iron rod is made up of atoms of iron. So let me draw the atoms. Atoms are closely packed. In solids, the atoms or molecules are tightly packed. So what is going to happen when you supply heat here? The heat energy will transfer from this atom to this atom to this atom. They are touching each other, right? And it will move little here and there because you are given heat. So slightly there will be more vibration, and it will hit each other, and it will transfer the energy from one atom to another atom, one atom to another atom, and like this heat is transferred throughout the body. And this process of transfer of heat is called conduction. So, what is conduction? Conduction is the process in which the heat is transferred from one part of the body to another part of the body by the atoms or molecules transferring the heat from one to the another. So, actually it is giving from here, it gives to the next atom, next atom, next atom, next atom. It transfers from one atom to the another atom, or one molecule to the another molecule. You understand this? So this is called conduction. Now, I will tell you something. Some of the metals are very good conductors, and some of them are not good conductors, right? So we have two differences. One is good conductors. Yes, some of them are good conductors, are simply conductors, and another group is does not conduct heat so easily, and they are called insulators. Insulators of heat, because we are talking about heat. So they are insulators of heat. So simply we will say good conductor. Silver is one of the best conductor. Silver is a good best conductor. Then you have copper and you have iron. Okay, these are then aluminium. These are all different metals that can conduct heat. Now, conductors are the material which conducts, allows. Okay, the word is allows heat to be transferred from one point to the another point. Insulators does not allow the heat to transfer from one point to the another point. One of the simple insulator is wood. You can take wood, or you can take, for example, like metal, like the backlight. You might have heard something like called backlight. Okay, so these are the insulators. Many insulators. For example, in your houses, cloth, fabric also, cloth is also, fabric is also not a good conductor. Okay, they are all insulators. For example, this, let go next step of it, which allows the heat to transfer, they are called conductors. Which does not allow, they are all called insulators. Okay, conductors and insulators we learned. I am going to show you one example here. For example, again take the gas stove. Okay, and the burner is here and the flame is coming. It is on now. Flame is coming, and I got a vessel here. In vessel we are going to make, let us keep water or milk, for example. Right, I wanted to heat this now. The flame is going all the direction and it is heating up. You will find that always with that there is a support, okay, which wanted to hold it. Yeah, there is like this. Now you'll find that this is also made up of stainless steel. Okay, but at the end of it, you will find that there will be a black color material. That is nothing but hard plastic, or it can be called backlight. I said to you backlight, or it can be wood. Yeah, because the handle of this utensil is nothing but vessel, is made up of an insulator. Why is it made up of an insulator? Why is it made up of insulator? So that our hands will not get burnt, right? We will not get the heat. So you will find that the handle of the utensil is usually an insulator. So that is one of the simple examples where you use the insulator, right? Insulators are used. See, for example, now different materials are there, different characteristics are there. Silver is an excellent conductor. Now what about iron, stainless steel? Have you seen that nowadays people say we will use copper bottom vessel. You see, copper bottom vessel. See, this vessel is there, what they do, they give a coating. For example, let me just take it like this, right? They will give a coating of copper, right? And this is made up of stainless steel. This is made up of stainless steel, but only the bottom is copper. This is copper, and this is made up of stainless steel. Stainless because it will not get stained easily, right? That is why it is stainless steel. And you know that handle is having already that insulator in it, so that your hands will not get burnt. Okay. Now why is this copper bottom? We have copper bottom because copper is a better conductor than the iron or the steel. So when you have copper bottom, cooker, copper bottom, why? Because the copper will absorb the heat so much, and quickly it will boil the milk, or it will boil the rice, or whatever the material you want to cook. It will get cooked easily, quickly, so that you can save energy. Okay, so you can save the energy. So these are about conductors. We can have more examples in your textbook. You can see, or when you come back to school, go to the library. There are so many ICSE books are there, where you have physics, chemistry and biology, right, separately for 6th, 7th and 8th, and learn that, and that is the basic physics, foundation physics for you, right? Now I move on to, from conduction, I move on to convection, right? Next mode of transfer, and that is called convection. Sometimes we use the word called convection, convection currents. Now what is convection? Very simple. Let us take a beaker, okay? Let us take a beaker, and I am going to take a burner, right, gas burner, okay, and I am going to heat it like this. I am going to heat it like this. So, okay, we can have a tube like this, okay, you can find this is called Bunsen burner. Bunsen or Bunsen burner. Bunsen burner also, you can say no problem, right? There will be a stand like this, from this gas will come, it will heat, you will find this in the chemistry lab. They will put a small stand will be there, a tripod stand will be there, and you can keep this on this. Now in this beaker, I have taken water. Usually we draw liquids dot 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 like layers. We draw like layers, because in higher class when you come, you will understand why are we drawing it in terms of layers. That is also a reason for that. They are all water layers are there. Okay, now what will happen? As I heat it, this is the surface, okay? Now as I heat it, the heat will first heat the energy first will heat this layer, the lowest layer, close to the flame. That will, first the glass will get heated, okay? And then the water, the first layer will get heated. A hot body, when a body is hot, its density will be less. A body which is hot, its density will be less. When it is density is less means it will become light. It will be lighter. It is lighter. So what will happen? This layer will move up because it is lighter. And this layer is a cold water. And the cold layer, see, hot is denser. Okay, density is more or denser. Okay, denser. Now cold layer, yes, it is heavier, it is denser. Density is lighter, so density decreases. It is lighter, I should not use the word denser. Density decreases, but cold layer is having more density. So what will happen? It is heavy. Okay, density is more means it is heavier. Okay, because of it is heavier, this will come down. Now the layer 1 is come up. Now layer 2 is come down. Okay, now this layer will get heated. Then layer 1 will go to up, third layer, and the layer 2 will come up here, and third layer will come down. Like this, this first layer will go on going up and up. And similarly, you will find that the heavier layer will come down. All the cool layers will come down step by step, moving up, coming down, moving up and coming down. All will be get heated together, and then you will find that this kind of motion where the molecules, you see water molecules are there. Water molecules are moving. In conduction, what has happened? You see, we took a metal, right? And we took iron. Iron molecules or atoms are there. Does the atom move? Atom does not move. Only the heat is transferred from one atom to another. But in the convection process, you will find that the atom itself is moving up and other atom is coming down, or molecules, H2O, water, right? So the molecules are moving up, the molecules are coming down. Really, the molecules or atoms themselves are moving, and that process is called convection. That is called convection. Convection takes place in the case of liquids as well as in gases. You might have seen, for example, land breeze and sea breeze. That is because of convection. I will explain land breeze and sea breeze in a separate video because that will take more time. And just to give you an example, land breeze and sea breeze also is due to convection. There it is gases, air molecules, and here it is liquid. The same thing I am going to draw differently and show you an example. Okay, let me just draw little differently so you understand little more better. Okay, everything is same, concept is same. Okay, diagram is going to be slightly improved diagram. Okay, now see, I got a beaker, and again I got a Bunsen burner, and I got a tripod stand, and we should place it on the top of it. Okay, like this. Now layers of water, H2O, water molecules are there, right? I can use the word atoms or molecules, I can mix it, no problem, that doesn't matter now. Yes, I have taken the layers. Yes, this much is enough. Okay, yeah. Now this is the topmost layer. Okay, layer 1, 2, 3, 4. Sir, how can we observe this motion? Now I am going to on this, and it is going to, flame is coming up and heat energy is given. Okay, and it is getting heated. When it is getting heated, I told you layer 1, 2, 3, 4, the layer closest to the flame, at the bottom most, it is less dense, so it moves up, and the heavy one comes down. The light one goes up, the heavy one comes down. What I do, I put a small pinch of a chemical called potassium permanganate. Dear students, you don't know about this word, don't worry. Potassium permanganate. Okay, don't worry about it. KMNO4. When you come to higher class, they will teach you. Right? Potassium permanganate, it is having a pink color. Violet, pink color. It will have a small piece, if I put, it is pink color. Now what will happen? When you do this experiment, you know the light, this layer has got hot, and it will move up. It will take little bit of pink color of potassium permanganate with that. First you will find that this area will become pink color. And you see further, again this area will become pink color. Here water will be without color, right? No color will be there. As the layer goes up and heat, hot layer goes up, heavy layer comes down, cold layer comes down, hot layer goes up, heavy layer comes down, cold layer comes down, and the pink color it will take with us, and the whole liquid will become pink color. This explains to you that the layer by layer the heat is transferred, and this is called convection. Convection is the process of heat transfer in which the atoms or molecules themselves move from their place, and that is called convection. Now that is very important for us to understand the process of convection, which I am going to give you an example, right? And then you will understand how it is being used. All the concepts of physics are related to our everyday life. Okay, all of them are related some way or other to our life. And a scientist is a person who observes. When you observe, then you see some phenomenon taking place. Then you think, okay, how is it related? What is the reason for that? When you question, observe and then question, and then you try to get a theory. That is how scientific method evolves. So, in the case of convection, you know, in houses, right? Big houses and all, you will have ventilators. Now, where do we fix the ventilator? Ventilators. Where do we fix the ventilator? If this is the room, let us say, okay, this is the room of a house. Do you fix a ventilator here somewhere? You know, ventilator will be just like a fan. Okay, you fix it here. You come to the chemistry lab, you will see ventilators are fixed. Ventilators are usually fixed on the topmost point in the higher level, right? Ventilators are fixed at the higher level. Why? Why should we fix a ventilator at a higher level, not at a lower level? Very simple. This is based on the principle of convection. You know what is inside the room? Air is there inside the room. You know, air, different molecules, carbon dioxide, oxygen, and nitrogen, like. Okay. Now, what will happen? Let us take a door here. We will keep a door here. And we will keep a window also here. Fine. Okay. Now, what will happen? In a summer or winter, any time. Winter is not so, hot, but let us say in summer, right? Now, you know, hot air will be there here, right? In lower part, air will be hot. Air will be hot first in the lower part. I said in the convection, hot air is less dense. Density is less. What will happen? This hot air will go up. Hot air will go up. As it goes up, the cold air will come down. Cold air will come down. Cold air will come down. This is hot air goes up, and cold air, which is more dense, because of it is heavy, and it comes down, right? And you know, outside, usually the cold air will come like this, and cold air will come and replace the hot air, and hot air will go out. Yes, and this process is called convection. So what is happening? In the case of a ventilator which you have kept here, yes, cold air will come, let us say, from inside. Anywhere cold air can come. It can come from here also, right? Hot air, cold air, it can come mixed up from anywhere. But by placing the ventilator up, what will happen? It will take up the hot air and it will go out, and the cold air which is here will come down, so that you will have comfortable heat inside the room. If not, the room will become very hot. That is why you need to have ventilators in the houses. Yes, modern days buildings, you know, they don't use so much of light, sun's light, and all that they have forgotten. People have forgotten, right? They use AC, all that kind of heater and all. But in olden days, and even now in villages where we are, you will find that we have mud houses. bricks, mud bricks are there because mud will absorb the heat energy, right? You know, we use water in a pot, right? Why you use pot? Actually, pot is made up of the mitti that you are using, the mud. Yes, they will absorb the heat so much, and the water inside will be cold. These are all natural ways. Yes, these are all the natural ways one can keep the environment and oneself better. So in convection process, the molecules, air molecules are moving up, the cold air molecules are coming down, and the cycle is being kept, and that is how it is going to be in the process of convection. And we come to the last point of our discussion on transfer of heat, and that is radiation. Radiation, very simple, right? In the case of radiation, sunlight is there, sun is there, sun is giving us heat, okay, and the heat is coming to us. In between sun and the earth, is there anything? Is there anything between these two? Yes, there is something, and that is, for earth there is an atmosphere. Atmosphere is a layer of air around the earth. And sun, from sun it is coming. Sun is very hot. The heat rays are coming. In between there is vacuum. There is nothing in between, right? No air, nothing, is vacuum. But radiation is coming. How? The radiation is coming. How? And that process is called radiation, or we say sun rays. Sun rays. The heat is transferred from one point to the another without any medium. There is no medium in between. What are the different types of medium? Solid, liquid and gases, right? There is no medium in between, intervening medium. So naturally the heat is coming, and this process is called radiation. Okay, so there are three ways of transfer of heat, and one is conduction, second is convection, and third is radiation. Dear students, I am going to give you a very simple example in which we will find it in everyday life, which you can easily understand this concept. So let me take, for example, your room. This is the classroom, okay? And there is a bench here, bench here, bench here, bench, bench and bench. Now students are sitting, right? Everywhere. Students, two students are sitting, right? It is a visualization, a picturization, imagination. Now, I give this duster to this boy sitting here. I give this duster to this boy, and I am standing here, okay? Now, I say to this boy, let us say the boy's name is Sham. I tell Sham, come on Sham, pass this duster. What he will do? Pass it. He will give this to next boy here behind him. And he will give to the next boy behind him, and next boy behind him, next boy behind him, and so it reaches the last boy. Let us say the last boy is Ram. It reaches Ram. From Sham to Ram, it reaches. Did Sham move from here? No. But what moved? Duster. So, duster here in conduction process, the molecule does not move. But only the energy is moving, the heat is moving, and that is process is called conduction. Okay, this is called conduction. Now think, I say to them, come on, do by the process of convection. Okay, now let us say I come to here, Sham is over, right, and I take some nice girl's name, Anita. Okay, Anita, and here who is sitting? Sunita. Okay, and it has to go from Anita to Sunita. But what is the process? Convection. The process is called convection. So here what will happen? Anita will get up from her place and give it to this girl behind her, like this. I'm going forward, right? You think in opposite direction, right? I will get up and go to give it to her, and she will get up and she will go and give it to this person, right? And again, see, she is moving and she is moving. Anita is moving till here, and then next girl is moving. This girl is moving. This girl is moving, and this girl is moving, and Sunita gets it, the duster at the end. She gets it directly at the end. Okay, by each person moving from their place, just like the water molecules moving from one place to another place, getting heated, lighter, moves up, heavier, comes down. And this process where the molecules are moving, that is called convection. What about radiation? Now, I am standing here. I have the duster in my hand. Okay, here, let us say, for example, some boy is sitting. Okay, let us not give name for this boy. Yeah, some boy is sitting. Now, this boy is not listening and he is sleeping. He is sleeping, he is putting his head down and he is sleeping. So what I do, I take this duster, directly I throw. Yeah, don't do it. Yeah, okay, you will get hurt. And I directly throw at this point here, right? I throw. See, directly it is coming and hitting. This is called radiation. In radiation, what will happen? The duster is moving directly. Yes, and sun rays are coming directly to earth without being transferred with any molecules or atoms. It is just shifting from one point to another point, and that is called radiation. Okay, this is how we can understand. There are three modes of transfer of heat, and one is conduction, second is convection, and third is radiation. I hope you understood. At least watch this video again and again, 1 or 2 times, then you will understand better. Thank you so much.